Hello, everybody. We're starting the next session now. We've got a fireside chat, and the wonderful thing about this summit, it's about quantum and AI, but very few people put them together. And we're now going to have Romano Rus, CSO and co-founder of Multiverse Computing, a company I happen to advise. And what I loved about them is the mixture of quantum and AI from the very start. And they've come up with an incredible energy solution, because the biggest problem we've got with AI is energy. And they've come up with a solution for that. And their investor, Olivier Tourneau, and Olivier, he's one of the founders of Quantum Nation, which saw the potential of quantum before anybody else did. So they've got the largest, and some would argue the best, fund in quantum out there.
So thank you all. Thank you for the invitation. Really glad to be here. And I would like to welcome everyone to the Basque Country panel. As a Basque from the French side and Roman from the Spanish side. So we are all, quite close neighbors. I would like to start maybe introducing ourselves. For my part, I'm Olivier Tourneau, partner and co-founder at Quantum Nation. So we are an early stage investment fund dedicated to quantum technologies. We did our first investment back in 2018, currently managing 250 million, and we have 35 companies in our portfolio. We first invested in Multiverse in 2019. Since then, we've reinvested 2 times, or is it 3? No, I think a total of 3 or 4 times. So, one of our favorite companies. What we liked about Multiverse, the first time we met was in Canada, and what we liked from the start is that Multiverse was able to do quantum-inspired as well as quantum. And we really thought that it was a bit too soon for pure quantum software, and that the real killer app was quantum-inspired. I mean, at least for the first 4 or 5 years, and I think, you made us be right. So maybe, Roman, if you could introduce yourself in a few words and then tell us about the journey. How did you create Multiverse? And how did you come to realize that what you can do with Quantum Inspired has some real usage in AI?
Okay, excellent. So thanks a lot. Thanks a lot, Olivier. And thanks of course, a lot, Karina. So when Karina offered me to be on a fireside chat here, of course I couldn't say no to Karina. Okay, so it's a pleasure to be here again. So yeah, well, I'm Romano Rus. I'm the co-founder and also the chief scientific officer of Multiverse. I'm also a professor of quantum physics. Okay, so I've been half of my life studying quantum systems, quantum computing, quantum-inspired methods to simulate quantum computers. And just following with the question that you asked, how come a professor of theoretical physics actually ends up building the largest quantum software company in the world, which is what Multiverse is right now. Okay, we started very small. We were 4 people. Right now we are 200, growing up to 300 people this year. We have offices in Spain, in France, in Germany, in the UK, in Italy, in San Francisco, in Milan, and so on. And the thing is growing and growing. So how did all this started? Well, I'm going to tell you a little bit about the story of Multiverse, because I think it's very interesting for those entrepreneurs here, okay? Because it's kind of also a little bit of inspirational. We were not born like the companies in Silicon Valley. They say they are born in a garage, okay? We are more modern. We were born in WhatsApp. Okay, we were born in WhatsApp. Actually, there was a WhatsApp group. Okay, that it was actually it came from a non-profit organization that was 2017. Okay, and we were trying to explore whether it was possible to apply quantum computing to solve problems in finance. We had a panel before, okay, about financial industry. By then, it was not very clear what was possible to do and what not to do. And in that, in that WhatsApp group, we were just discussing what was possible to do. Now, as always, when you set up a group and nobody's paying, out of 20 people, there were only 3 people working. Okay, and guess who was that? Those were the 3 founders of Multiverse Computing, right? So From that WhatsApp group, we ended up writing a review paper explaining what was possible to do using a quantum computer to improve the processes in the financial industry, what was possible, what was not possible, and that paper was extremely successful. Okay? That's when we realized that we had something very valuable. I was at my office at the university, and I was getting calls from JP Morgan, from Morgan Stanley, from all these people, and I realized that that was not normal, right? And then we decided to start the company. That's how Multiverse was born. So Multiverse was born in 2019. We were 4 people, the 4 founders. You have 50% of the founders here, okay? I'm 25%, Enrique is the other 25, all right? So you are very lucky today. And then we went to Canada. We went to Canada to an accelerator that is called the Creative Destruction Lab, which is the largest accelerator of quantum companies worldwide, essentially. Many well-known quantum startups have gone through this program. We went there. We graduated through the program, and that's where we met our first investor. That was Continuation, okay? Yeah. And from then on, it just kept going and going. Okay. Now, how come did we actually end up doing quantum-inspired methods for AI? Because we were doing software for quantum, for finance, okay? But at some point, we also realized that we could open to more verticals. So we started working also in energy, in logistics, in manufacturing, in defense, in cybersecurity, and so on, because we were doing solutions that had to do with optimization and also with quantum machine learning. But we also had these quantum-inspired solutions that you were mentioning before. We were very unique from the beginning because these quantum-inspired solutions, it's actually what I built my academic career on. I invented some of these algorithms. This is the reason why I became a professor. So I really knew how to apply that to quantum. The interesting thing happened when we had a project with Bosch, actually, the manufacturing company, where they told us, hey, could you apply this also to improve, we have a machine vision system here. We think it will be possible to improve it using quantum-inspired. We tested that, it worked fantastically well, and then we realized that we had something very valuable. It turns out that using these quantum-inspired methods that originally you devised them to simulate quantum systems, we could also improve AI models. Now, there is nothing quantum in AI. It's purely classical, but when you have a look at the mathematics, you have the same bottlenecks, or at least very similar bottlenecks, mathematically speaking, to the ones that you find when you want to simulate quantum. So, okay, so we just went there with all these techniques. It was working. Then we started doing neural networks with quantum-inspired methods, deep learning, and so on. And then the best thing that could ever happen happened, which is that in 2022, ChatGPT came out. We had large language models. It was kind of a revolution, okay? But the problem of large language models is that they are large, all right? They are super heavy. They have trillions of parameters. You cannot deploy them on your iPhone because it's just too heavy in terms of memory, no? We tested whether our technology could make these models more efficient, and it worked. It worked fantastically well. We tested that in 2023, and we realized that we could compress the LLMs by then around 90-95% without almost losing any accuracy. And from then on, we have been working more and more on the compression of AI. Okay.
I think very interesting. And I think one of the key to the success of Multiverse is that from the start, you were looking for clients and not looking for grants. And one of the pitfalls we see for a lot of companies in quantum is that you survive out of grants, but you don't know what your client expects from your company, so you don't develop the right product. And what's remarkable is that exactly what you mentioned for Bosch, you developed for a client, and then from that you understood what was that the market was expecting. So I found this very interesting, and probably we've not seen another company in the space with so many different clients and so many different use cases at the same time, which was quite remarkable for a small team, and also a bit worrying as a member of the board. Can you tell us now what are the 2 main products that Multiverse is doing, and who are the typical clients? Maybe some practical example of what are the use of your product. You already mentioned Compactify. Maybe you can elaborate a little bit?
Yeah, exactly. So exactly. So we have 2 products. We always, since you mentioned that, we have always been working from the very beginning, very close to the client. It's the client that tells you the problem, not the other way around. And this is a big problem in quantum companies, that they say, no, we are going to educate the client. No, you don't have to educate anybody. You have to go to the client. The client already has a problem, okay? And they tell you the problem to you. And you are responsible for solving that with whatever technology that you have. It can be quantum, it can be AI, it can be whatever, okay? So we took this attitude from the very beginning, and it worked extremely, extremely well, because at the end, if you are building a business, it's about clients, all right? And then we elaborated two products. The one that we have right now is which is growing more, is Compactify, as you say. Compactify is a compressor of AI models in general, okay, using quantum-inspired methods. Now, this is a compressor that works particularly well for LLMs, for large language models, but not just for that. It also works for image recognition systems and other types of methods. We have been applying that to a super large variety of use cases, okay? We have been applying that for image recognition systems, let's say for pattern detection in manufacturing, okay? Also for observation of the Earth in satellites. We have been deploying, we have projects to deploy that in our algorithms. And when it comes to large language models, then the number of use cases is just infinite, okay? Because you can compress the models a lot. You can make models that are really very, very small, okay? And they are so small that they fit in your iPhone, they fit in your Apple Watch, they fit in your toaster, in your microwave oven, and so on. And you are going to end up having these nano models deployed everywhere. The future is going to be run by AI. We are going to have AI absolutely everywhere, in all the devices, running locally on the edge without a connection to the cloud. And you can only do that if the model is sufficiently small to run on the edge. And for this, you need very, very little resources. We can deploy them on drones. We can deploy them on self-driving cars. We can deploy them on submarines. In a submarine, this is a very constrained environment. You don't have a connection to the cloud. You need something that runs locally, okay, on a satellite, okay? So we have projects going on with this, in all these things.
So on the one side, very large model, large size client, where you will compress the model, and on the other side, developing nano models that can be used on premise but not consuming a lot of energy and a lot of compute power. So, I was challenged, at the ChatGPT moment, I was at a conference, and some people asked a question, which was, now that we've seen so much progress in AI, what you are doing, Olivier, is dead. We will not need quantum because of AI. We believe it's quite the opposite, and we believe those technologies are quite complementary. Now, what's your view, what's your take on what AI can bring to quantum, but what quantum can bring to AI as well?
Yeah, correct. So it's not, AI is not going to kill quantum. It's impossible by principle, because there are some problems that you cannot solve with classical AI. Okay, just like that. So quantum is going to come, yes, that's for sure. Okay, quantum is going to help us solve some problems that are impossible to solve today, even if we have all the computational resources of the world and all the best AI and so on. Yes, that's also going to happen. Now, when it's going to happen, we'll see. All right. Now, my opinion is that these two technologies are going to live together, okay? And we are going to end up having the best of both worlds, okay? So both quantum and AI, both of them are deep tech, okay? AI is very impressive, what you can do with it. But we can do it better with quantum. With quantum AI, okay, we can also teach a quantum computer to talk. All right? In the same way that we have large language models, we can also have quantum large language models. We can deploy this on a quantum computer, and once it is deployed on a quantum computer, we can improve it beyond the capabilities of a classical GPU, okay? We know how to do that. We have filed patents about that. Now we are running the first test, and I think the future is going to go in this direction. We're going to have hybrid algorithms that are going to be running these quantum machine learning models, okay? And at the end, we are going to have models. Some of them are going to be running locally, probably with quantum-inspired techniques. Some others are going to be running on the cloud because will be too large, or perhaps you need a quantum computer to run that, okay? And you will not notice. You will just at some point have a device, you will make a request to the device. There's going to be a router in the device that will decide whether the thing is going to be processed locally or on the cloud. And if it's run locally, it's going to be with quantum inspired. And if it goes to the cloud, it's going to be on a quantum computer. And I think that's the future.
I think another nice example of what quantum can do for AI is about inventing sets of data. So for some areas where you need to train the models, you will need a lot of data. It was Luc Julia who said, if I need to train a model and to show him how to understand that this picture is a cat, I will need to show 500,000 photos of a cat. If I do that with my 3-year-old, then it's only 2 photos. But so that means we need a huge number of data, sets of data to train the models. We sometimes don't have them at scale. We sometimes don't have them and if you train the models with the wrong data, not good enough quality, then the model will collapse. The more you train it, the more it will fail. So there's also a challenge in being able to come up with this synthetic set of data. And actually, some companies we've seen are starting to use the intrinsic randomness of quantum computers in order to generate synthetic set of data to train the AI model. So that's probably also one of the most unexpected applications, but quite interesting from quantum and AI. Now, there's also a fantasy that you will be able to run the model on the quantum computers, and so that it will save energy and time. Now, with the machine we have today, it's probably a few years at least away. What's your take on when will those quantum machines be able to do something useful for AI?
Well, actually, when are quantum machines going to be able to do something useful in general? I think that today, okay? Because these quantum processors that we have today, they are small, they are noisy, they are not error corrected. We don't have 1 million qubits yet, and so on and so forth. But they are not useless. We can start using them for solving some practical problems. One problem was said before in the finance panel. The guys from HSBC, together with the IBM people, okay, they solved a very interesting problem in finance. Okay, that was one example. But at Multiverse, we also specialize in identifying these use cases that you can solve with a quantum computer and where you can obtain business advantage. We have lots of examples in all these different verticals that I told you. Predictive maintenance, optimization of portfolios, and so on and so forth. Now, when it comes to AI, this is very interesting because it's actually possible to include quantum computers even if they are not fully error corrected and so on, if they are small, noisy. You can use these machines already to improve classical AI models. Okay, so you can devise hybrid algorithms that, okay, they are going to involve some quantum and classical processes, okay, but you can already start using these small quantum processors with hundreds of qubits, so it's not so small, okay, to enhance classical machine learning. We know it's possible. We've done that, okay? And I think we are going to start to see the first important implications in, I would say, a couple of years at most. Yeah.
Excellent. So you are, let's say, working at the intersection of probably one of the two biggest buzzwords that we have today, quantum and AI. How do you do to avoid overselling? How can you keep feet on the ground and deliver what you tell your clients and not overpromise?
That's an important question. So how do I keep away from hype? No? Well, here is the Enrique Lizaso law, who is my co-founder, is that if you are selling, there is no hype. Okay, so I think he's right. Okay, so if you are offering something of value, it's actually more precise than that. If you have recurrent customers, then there is no hype. That's exactly the law. If you have recurrent customers, then there is no hype. Why is this? Why is this? Because, well, if you sell something of value to a customer, if it's really of value, they come back to you, so then there is no hype by definition, okay? You are offering a solution, that is more malleable than the actual solution that the customer has, all right? Since the very beginning, we have been focusing on this at Multiverse, okay? We are not overselling what we can do. We are trying to improve the processes of the client. And here again, I come back to the very first thing that I said, that it is the client that tells you what is the problem. And this is a professor of theoretical physics talking about clients, okay? So that's, but it's true. It's the client that tells you the problem. Once you really internalize this, it's okay. I mean, you understand what is the problem, you understand what you can and what you cannot do, you work very hard, and at the end, you end up offering something of value. And this is the way in which we avoid the hype.
So I will have one last question. If you had an advice to give to someone who wants to work at the intersection of quantum and AI, what would that advice be, apart from joining Multiverse, of course?
Well, obviously, yeah, 4 advices. No, first join Multiverse, okay? No, so if you are an entrepreneur, you want to build your own quantum or AI company and so on, the very first thing I would say is that go for it, okay? Don't be shy, okay? I have many friends in academia that are working on very interesting technology, they don't make the jump to industry because many of them, they just say, well, look, but what I'm doing is very far from the market. And then I always explain the same story. And well, look at me, I am a professor of theoretical physics. I was working hold on quantum-inspired methods with tensor networks to simulate strongly correlated quantum many-body systems, okay? Now, you tell me how far is that from the market, okay? Now, if the market is very far from you, what you have to do is you go to the market and you bring it closer, period, okay? So that's exactly what we did. And now we are very close to the market, okay? So that's my first advice. The second advice is please don't be humble. You go to play large. We have to play with the Americans. We have to play with the Chinese. We need very large investments. You need to build very large companies. Otherwise, it's impossible to compete. And if you are small, you are going to stay irrelevant. It's sad, but it's true. This is how the game goes, okay? And you have to grow very fast, very quickly, and really strong, okay? And then, obviously, my third advice is please talk to Olivier, okay, and with Quantum Nation, who are great investors, right?
Thanks, Roman. So I will have one other question. Since you mentioned the Chinese, a bit of a controversial one, maybe. What's your take on DeepSeek?
Oh, well, we can compress it 90%, I can show you. So yeah, we can improve it by far. And we can also remove the censorship. We can also have a version of DeepSeek that can explain you what happened in Tiananmen Square and so on. So that's also something that we can do.
And I think you also have another product which we did not mention, which is about making sure about the accuracy of data and what's been done to. Okay, can you also elaborate? Because I think the integrity of data is also probably.
It's very important, and this has to do also. It connects with my previous comment that we can remove the censorship of DeepSeek. We can also modify or remove or add information on models. Okay, we call this the lobotomizer. I know it's not very politically correct, but you will never forget the name because we can actually erase the information, like cutting part of the brain of the model. Okay, so we can do that using our quantum-inspired techniques. We can alter the information. Okay, we can inject data. We can remove data, not add filters, but actually remove it directly. Okay, or we can remove censorship. Yes.
Thank you, Karina. Do we have time for maybe one or two questions from the audience?
Wow, everybody's so impressed. Yeah. There is one. Okay. Yes. Oh, hold on.
Thank you very much. Probably just building on what you just said, so I won't repeat the name, but if you can take data out, can you reverse the process? You said you can reverse the process for censorship, but can you also apply the same technique for looking at, so in my example, it would be the quest for dark matter, trying to find or see dark matter. So could you look at data in order to get better insight from large data sets like Xenon IT in order to speed up finding evidence of interactions of dark matter?
Correct, yes, I think we could, yes. Actually, it's something that is generic to the model. We can just alter, modify, remove, or filter the important information from a model, and we did it for a large language model. Okay, and the model was talking about I don't know what, and then we modified that. But if it is a model that is trained with images from astrophysics or data from from collisions of galaxies or something like this, we can also do that. Yes, I don't see a reason why it shouldn't be possible. Yeah.
Thank you.
Thank you, Roman.
There is another.
Tanya.
Thank you. It's a very specific question around working with defense. How do you get around export controls?
Oh, around export controls. Yeah, that's a good question. So far, we have to, we are working, it depends on the model that you are working on. Okay, so far we have been compressing mostly European models, also the Chinese models. Okay, and I guess that obviously, this technology is the same as for quantum technologies. These are technologies of dual use, so there are constraints on them. Okay, and then depending on what type of model we are going to be deploying, we'll have to choose, and on the region, okay, we are going to have to be choosing this model or the other model. Okay, perhaps an European or perhaps an American model, like the guys from Meta, and so on. Yeah.
Thank you, Roman. I think the boss says that we have to stop now.
People are hitting up. Very good, very good. Very good. This is a good signal. Okay.